Okay, we're going to go ahead and get started with our first summary frame, so you should be able to find this in the packet. Notice that it does refer to pages 460 and 461 in your notes. Under what conditions does a series represent a function? Well, early on in this discussion, we see that if I can write out a series term by term, such as this series, which I will refer to as base from now on, I know that this represents the function 1 over 1 minus x. But that's only true if the absolute value of x is less than 1, or in other words, if the interval of convergence is between -1 and 1. If I try to take a look at this series and this function on an interval other than -1 to 1, I will find that they do not converge. They do not lay on top of one another. So those are the conditions when a series represents a function, when we are on the interval of convergence. So moving on to question number 2, what definition is used to establish that the summation of 4x minus 3 to the n is a power series centered at x equals 3? Well, that is something that we find in your notes, or in your book actually, on page 362. So I find that this is equal to f of x is equal to the summation n equals 0 to infinity c sub n x minus a to the n power. And if I wrote it out term by term, that would be c sub 0 plus c sub 1 x minus a plus c sub 2 x minus a squared plus dot 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 c sub n x minus a to the n plus dot dot dot. I can find that on page 362, and it goes on to say that this will converge as long as the absolute value of x minus a is less than this capital R. This capital R is referred to as the radius of convergence. But in all actuality, you really don't need to be scared of that, because that's something we're going to be looking at a little further in problems that we're going to see soon. Moving on to number 3, this question is asking what definition is used to establish that the summation of 4 times the quantity x to the n power is a power series centered at x equals 0. Well, that can be found on the top of page 461. So this is our definition of a power series. And that definition is the summation of n equals 0 to infinity c sub n x to the n is equal to c sub 0 plus c sub 1x plus c sub 2x squared plus dot 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 plus c sub n x to the n plus dot dot dot. This is a power series centered at x equals 0. Now, based on what we learned earlier in our packets, we should be able to find the interval of convergence. Note that if I take this series given 4 times the quantity x to the n, that would be a situation where I could actually pull the 4 to the outside. Or if I wrote it out term by term, similar to what we did above, this would be 4x to the 0 plus 4x to the first plus 4x squared plus 4x cubed plus dot dot dot. Or in other words, that's equal to 4 plus 4x to the first plus 4x squared. and so on. So this 4 really doesn't impact what's going on inside of the sequence, other than to take every term that we have and multiply it by 4. So in terms of the interval of convergence, the way we solve this problem is we really just have to focus on this piece right here. And we know from what we've already learned that the interval of convergence is found by taking the absolute value of x less than 1 and rewriting that minus 1 less than x less than 1. This is our interval of convergence. This is where our series will converge on top of our function. So that's the next question, is what would the function be? Although that's not what we're being asked. So based on what we saw in question 4, to find the interval of convergence for this power series, our first step would be to take the 4, bring it to the outside. And now this will converge as long as the absolute value of x minus 3 is less than 1. So similar to what we did above, we're going to rewrite this expression as minus 1 less than x minus 3 is less than 1. And now we need to get x by itself. So that would require us to add 3 everywhere. So then I would have 2 is less than x is less than 4. So I want to take a minute to prove some of this is true, especially the last one. So I'm going to grab our calculator and I'm going to go ahead and put myself back into function mode since we're done with our work with the polar. So I'm going to go ahead and add a graph. Alright, so if we're going to put in question number 5 on our summary frame, the first thing I'm going to do is start writing out the power series term by term. So that would look something like 4 plus 4 times the quantity x minus 3 plus 4 times the quantity x minus 3 squared plus 4 times the quantity x minus 3 cubed I'm going to go ahead and stop my video.